Imagine this. You're an engineer at NASA's Deep Space Network. You're sitting at your workstation, monitoring the health of Voyager 1, the most distant human-made object in the universe. A routine transmission has just arrived, except something's wrong. The data doesn't make sense. Instead of the expected numbers, coordinates, thruster status, temperature readings, you see strings of zeros, strange, 377s, and nonsensical values. Voyager seems to be reporting that it's doing things it physically cannot do. Is it turning in the wrong direction? Is it spinning? Is it malfunctioning? But here's the strange part. Is still receiving a clean signal. It's strong, stable, and coming from the right direction. If Voyager were actually turned away, the signal would be weak or missing altogether. Yet everything seems fine on the surface, except for the old garbled telemetry. Welcome to the bizarre world of deep space troubleshooting. You see, every command sent to Voyager and every bit of data received takes over 22 hours to travel one way. That's 44 hours round trip. It's like trying to have a conversation with someone across whose light days, not light seconds. It's no longer texting. It's like sending letters by bottle across a cosmic ocean. In this scenario, NASA's engineers suspected that Voyager's Attitude Articulation and Control System, AACS, which tells the spacecraft where it is pointed, was feeding data to the wrong memory location. That means Voyager wasn't actually turning. It was just misreporting what it thought it was doing. Even more importantly, the antenna was still pointed perfectly at Earth, or we wouldn't be receiving anything. But how do you fix a spacecraft? Launched in 1977, built with computers less powerful than a modern calculator, and running software written in languages most current engineers have never used, very carefully. Teams at NASA began replicating the problem, using ancient codebooks, schematics, and simulated models of the spacecraft's behavior. Every command had to be planned with surgical precision, because a single mistake could permanently silence Voyager. Eventually, they traced the issue. A corrupted bit of software was telling the AACS to store orientation data in the wrong place. Fortunately, they were able to reroute the data, bypass the faulty code, and restore Voyager's ability to report accurate information. Problem solved, for now. But the deeper truth is this. Voyager is getting old. Its power is dwindling. Its components are decades past their expected lifespan. And yet, like a wise elder, it still whispers across the stars, one packet at a time. These kinds of glitches are becoming more frequent, more unpredictable. The engineers know that someday soon there will be a final message, one last signal before Voyager goes silent forever. But until that day, they will keep listening, because every byte from Voyager is precious, not just as science, but as a symbol of what we can achieve when we dare to reach beyond. Here at Infinity Beyond, we see this moment not as a failure, but as a testament. Even when the spacecraft speaks in code, even when the software hiccups and memory glitches, the human spirit of problem-solving endures. Voyager may be alone out there, but it is not forgotten. It still carries our dreams, our knowledge, and yes, our imperfections. And as long as we can decode its cosmic whispers, Voyager reminds us that even the smallest signals from the farthest places can still all bring us home.